Okay, let's go ahead and look at a more complicated example of factoring a difference of cubes using this formula. So this time we want to factor 27x to the 12th minus 64 times z to the 18th. Okay, now before we can apply this formula, we have to identify what is a and what is b. Well, first we have to see what's being cubed. Okay, if we look at each term individually, determine what's being cubed, then we can find our a and our b. So in 27, we know that's 3 times 3 times 3, which is 3 cubed. Okay, and in 64 is 4 times 4 times 4, which is 4 cubed. Okay, now how about the x to the 12th and the z to the 18th? Well, x to the 12th, we want to express that as something cubed. Well, we know 12 is 4 times 3, so x to the 12th is going to be x to the 4th cubed. Okay, so remember that's one of the rules of exponents there for variables. And z to the 18th, we want to express that as something cubed. Well, remember 18 is 6 times 3, so z to the 18th is just z to the 6th cubed. Okay, so 27x to the 12th is going to be the quantity 3x to the 4th raised to the 3rd power. Okay, 3x to the 4th raised to the 3rd power. Okay, that's what 27x to the 12th is, because 27 is 3 to the 3rd power, and x to the 12th is x to the 4th to the 3rd power. Now how about this other term here? Well, 64 is 4 cubed, z to the 18th is z to the 6th cubed, so 64z to the 18th is going to be the quantity 4z to the 6th cubed. Because again, 4 to the 3rd power is 64, and z to the 6th to the 3rd power gives us z to the 18th. Okay, so that's that. Let's go ahead and erase some of this stuff down here, just to give us some more room to work with. Okay, now if we continue with this formula, now what's our a and what's our b? Well, the a is this first part being cubed, and the b is the second part being cubed. Okay, so a is the entire thing in the parentheses here, b is the entire thing in the parentheses here, because this is all that's being cubed, 3x to the 4th, and this is all that's being cubed over here, 4z to the 6th. Okay, so let's go ahead and just continue with the formula now. So when we do that, what are we going to get? Well, the formula tells us it's going to be the quantity a minus b, which is 3x to the 4th minus 4z to the 6th, multiplied by the quantity a squared. Well, a is 3x to the 4th, so we have 3x to the 4th, that whole thing squared, plus a times b, so plus 3x to the 4th. That's our a, multiplied by our b, which is 4z to the 6th, and then plus b squared. So plus the quantity 4z to the 6th squared. Because 4z to the 6th, remember that's our b, so that's a squared plus a times b plus b squared. Okay, now when we simplify, what do we get? Well, 3x to the 4th minus 4z to the 6th. Nothing really we can do with that. But then in here, 3x to the 4th, if we square that, 3 squared gives us 9. X to the 4th squared gives us x to the 8th. Okay, because 4 times 2 is 8, so remember those rules for exponents and variables there. Plus, what happens over here? 3 times x to the 4th times 4 times z to the 6th. 3 times 4 gives us 12. X to the 4th, z to the 6th. Nothing really we can do with that. And then the last term inside of here, 4z to the 6th, all that being squared. 4 squared is 16. Z to the 6th squared is z to the 6th times 2, which is z to the 12th. Okay, and that's the result that we get when we factor this nasty expression here. Well, this expression isn't so bad, but when we factor, we kind of get this little mess here. So if we factor this difference of cubes using this difference of cubes formula here, this is what we get right here.